Alright, part 2, final sprint. We are on final bit of collisions. Well, actually, we're about halfway through. Got collidable groups next. Although I've kind of gone over most of this, to be honest, so I can kind of breeze through what's left. Hopefully. Sorry about fumbling around so much last video. That was not the best. Not the best. Anyway, we want to get collision group. Right, okay, so collision groups here, got all the same things from before, but now we have some accessors for a group AABB. So, what this is gonna look like here, we update the group AABB by going through all the well, first we make sure that the size of the collection is greater than 0 because otherwise that screws it all up. And then we go through each B-sphere in the collection, or in the collection, each default B-sphere of the collection of collidables. And we call compute data on it using the method I wrote for it. This one right here, which just basically calculates the this is the right one, right? Yeah, calculates if it's can be made into the max or the min. It's based on its call it using the radius on the center to get the max of each value and then the min of each value, so that you can create a quick AABB. And then if either of those happen to be the corner for the box, then it will change it. So where? Oh yeah, each one of these, really. Yeah. So that's that. Right, updating group AABBs. Accessor actually probably should look at where it's updated at. How that whole process goes along, which will kind of lead into the collision manager here, I believe. Yes. Very good. Right, so we got our compute group AABBs method here, which is called somewhere magical, I believe. The scene. Although I can't quite remember if this is actually where it is or not. Huh. I guess it's not. Alright. It's probably in scene manager? You know what? Faster way. Give me references. And all this stuff gets jumbled together. Oh yeah, in the scene. I just totally passed it. So yeah, it computes the group AABBs right before it at the scene level, right before it processes collisions. So that's pretty neat. And all that. That's how that goes. How we update the group AABBs. So new companion pattern for update group AABB from this. So command pattern to update group AABB from collision manager. I just updated it at the scene level. I have a feeling you're gonna get angry about me not doing it the way you wanted me to do it. Huh. Command pattern? That's a different. Yeah, I mean, I guess I could see it, but I don't know. I feel like it's a lot easier to just call it at the same time, or right before you call process collisions in the scene. Same process, just I don't know. Either way, it works out, right? Although I have a feeling you're not gonna like my solution because you never like my solutions. Anytime I go off the reservation, it always ends up bad. Uh, anyway, collision manager, new process triggering collision group updates, new commands and associated command. Oh, we just went over that. Structure with proper cleanup. Well, I mean, might as well look at the structure, right? It should work fine and dandy. Actually, I don't think it's changed. Yeah, I don't think it's changed at all because the collision group handles its own cleanup. Oh, except for these two. Oh yeah, here's the thing I was talking about earlier. So I've got these two strategy patterns here that um, change whether the it changes how the each collision test command is handled. So basically, this you can change out for the visualized processing method or the standard processing method, and it will execute the collision commands depending on which one it is differently. So we might as well jump the gun a little bit here and look at test commands because otherwise this doesn't make any sense and I sound like a raving lunatic, which is, so we'll just look at pair test command here. So we've got our execute function here, right? So we've got our different layers, which go into more in depth in a second once I finish my point here. Then we have execute visualized, right? So if I were to be using the visualized command pattern when I call the execute command on the collision test command, it will call execute visualized, which is this method we were just looking at here, which as you can see is a little larger because it has all the visualized commands in it. So this is a fast, efficient way of, at least I hope it's efficient. I tried something new and different here, so I'm really hoping it's not like all the other times I tried something new, different, and clever, where you hated it immediately. But as far as I know, it's sufficient. Right. Anyway, we've got all our visualized commands in here at each level, which is what you saw earlier, and it can be enabled or disabled in the scene, depending on what you want. So when we're playing the game, you obviously don't want all that in there. And self collision is the same, just less tiers, as you would expect. Right. Probably look at those again to look at the tiered collisioning in a second here once we get there. Which actually, let's just go right back. Right, so we've got our group ABB. So we intersect with the group ABBs by, accessing the group ABBs. And then we got the default B-sphere layer against the ABB. So we check the second group here, so it's ABB. Then we check it against the first one's B-sphere. Then we check. Then once you pass that, then it means they're both inside of each other's group AABB, which means that they're potentially more likely to be colliding. So we'll go on to the B spheres, which are nice, cheap, and efficient. And if that's colliding, then we test it against whatever volume it's whatever collision volume the user used to get a little bit more accurate, or Anyway, yeah, it's the same down here, just all the visualizing commands for each one. Right, so we'll look at self collision, which is the same, just less tiers. So there's no group A BBs because there's no point. And I think, yeah, yeah. Actually, did I miss one? I might have missed one. Hmm. There might actually supposed to be an AABB here against, like, if you're testing yours. Well, wait, no, I'm crazy. No, stop saying wrong things. Stop saying wrong things, Tony. Right, yeah, because they're in the same group. It makes no sense to test the same group against this group AABB against the same group AABB. So therefore, we only test whether their p spheres are colliding, and if that's true, then we can test their actual collision volumes. So a lot less to do here. And of course, we have the same stuff down here, just more visualizing. Right. How are we doing for time? 11 minutes on collisions. I think that's fair. I believe we're moving on to a visualizer. Const references to collisions, ideally. Yeah, I'm pretty sure we did that. Pretty sure. Yeah, we got our const references. I did good, Andre. Please be merciful. That's not what we want. Right. So we got our levels of testing. Yeah. Four levels for pairwise, 2 levels for self-testing. I'm not crazy most of the time. New test for tiered collision. Describe terrain collision. Okay, so I don't have terrain collision yet. Sorry about that. I behind. Anyway, visualizer. So we gotta look at the visualizer. I'm pretty happy actually where the visualizer's at right now. So yeah. So here's a quick look at the its turning in case you wanted to look at it. Got some methods here for interacting with the its commands. So yeah, I've got a command for the B sphere and then also another box command. So this is rendering and recycling those. And then of course we got we can visualize and terminate. I don't know if I showed it, but I like a long time ago I changed out all the, like, from last quarter you told me to change out all the terminates. I don't know if I ever showed this actually. But yeah, no, they're all turnies. Yeah. I remember being annoyed at that because it's so simple. How could I have missed that? Anyway, visualizer. So we don't need to look at the attorney anymore. Right. So we got our singleton here, visualizer. Got all the commands to visualize things. I finally got the drop line working. I've had the draw point working for a while, and I've been using that quite a bit to my workhorse. But draw line, I finally figured out, like, almost too late how to make it work. The math was fun as usual. Is there anything particular we want to look at here? Not really. Okay. So not that much has changed up here. Do I need to show the stuff and things. So it should be significantly improved. Yes. Maybe we don't have all the bells and whistles, but I've got a pretty good visualizer here. I'll render request done through command generator with recycling pool. Yes. I believe I had that last quarter too. Yeah, we've got our recycling here, or well, cleaning up the recycling there. Where's the right? So yeah, you can see, when you get a new box command, recycle or use recycled ones, and we've got recycle methods here. Right. So neither requests nor commands should create new graphics objects. Yeah, obviously. Never had graphics objects in the engine side before. I don't know why I would start. Uh, Main methods. Others may exist. Show all bounding volumes. Overload options for user friendliness. I do have a couple overloads. Maybe not as many as I could, but especially for like the AABB. Additional tools, marker lines. I do have, point lines, but none others. It's hard enough figuring out how to make the line thing work. Render all. Yep. Delete. Support class colors. I don't know if I've shown colors, but we have colors. Houston. We have colors. All the colors. All the colors you could ever want. Anyway. Momentary insanity aside, here's all our options for visualizing. Just one option for the OBB. We've got our ABB using the collision volume, and then just with the max and min for the terrain specifically is why I have that one. Regular B sphere, show collision volume. This may actually be an older method. It's no longer needed, unless that's what the C debug for the debug. Well, that triggers the debug. Excellent, outstanding, good. Then of course we got draw line, draw point. Let's see here. Right. So yeah, this figuring out the math for this took me way longer than it probably should have. But 3D math is not my strong suit, unfortunately. Yeah. And then point, just put the box at the point. Easy enough. I might show some of this with using this with the terrain, showing off like normals and stuff. Yeah, how are we doing? Oh, it's gonna be another 20-minute video. Woo. Whoopee. Request nor commands to create graphic objects. Yeah, pretty much. Actually, I mean, I've showed this a long time ago, but I'll show it again because no one remembers anything, especially me. Let's see. So we got our visualize commands here. What's the base class look like? Yeah, I got a set info and a get color. Execute and recycle. Stores a matrix and a color vector. Neato. Right, so the execute just renders it, recycle. This is yeah, it goes through the visualizer attorney, which I showed earlier. Yeah, earlier. Before I looked at the visualizer. Yeah. And box, the same thing. Just box. Yes. I believe that's everything we need to look at for visualizer. Right, math tools and terrain. Let's run through math tools again real quick, in depth, before I cut this video off. Right. So close all these things up. Math tools, you and me. Right, so we got our B sphere intersects. And yeah, so intersects B sphere, uh, and then on an AABB, basically, just checking the center and radius against the AABB. Then similar clamping with the OBB. This was fun to get working, as you can see by the old debug using the draw point. That was before I had the line function. Oh, that's, yeah, the dark days. Right, so AABB intersects basically with, if there two AABBs intersect each other, we got our 3-axis test here. And then the OBB intersect that I showed earlier. Yeah, I'm actually pretty proud of this. I hated it so much for so long, but once I got it working, but actually first I cleaned it up because it was a hot mess before, just because like the functions were not good, because I wasn't passing down the collision volume, like, because I was being dumb. Yeah, now it looks beautiful and it works beautifully, and I'm happy. Right, and then we got these 3 methods here are just checking the axis overlap and then getting the 2 different projections for that test. Then we got our test interval test, which I think goes with can't remember what this goes with, but I think it's for testing with AABBs. Probably AABs against AABs. Yeah, we got our clamp point here for, clamping a point to a particular line or vector. But basically it's to clamp the point on AABB for those tests. Then we got clamp to axis here, which is, oh yeah, clamp point uses clamp to axis to do its thing. Yeah, obviously. And then, oh yeah, that's right. Test interval is the individual test that is for the test axis. So yeah, you test the y, the x, y, z axis for 2 AABBs, and then each one calls the test interval to test the x or y values, the min and max against each other. Yes, it's all coming back to me. Right, so that's the math tools. Yeah, I didn't like put too many extra tools in there, I don't think, but got a pretty healthy mix here. Right, I think I'm gonna cut this video off here, and next time we'll look at a new section.